Today I'm going to be talking to you guys from a high level of why sometimes the most accurate machine learning model might not necessarily be the right one to use. So a question to ask you guys is, how many of you have done like a logistic regression, linear regression, something in a stats class? Yeah, most of you. So this will be very applicable to you guys. So for many of you aspiring data scientists, I think this talk is very important because at some point in your career, you're going to be in a conference room and you're going to have some business person ask you, explain to me this model. And it might be very difficult if you have a very complex model where it's not just as simple as A plus B equals C. Something I want to highlight, I know Kyle really talked about becoming a data scientist and what's important, what are some important things about becoming a data scientist. But some things I just want to highlight about, we are trying to create meaning from raw data by using scientific study of creation, validation, and transformation. Our objective is to develop reasoning, discussion, or calculation that must be processed or analyzed to be meaningful. And then also we want to give computers the ability to learn without being explicitly programmed. And usually we do this by optimizing a model to find the lowest mean square error, best accuracy, lowest log loss. And for my discussion, this is what I really want to highlight upon. So I'm going to give you a practical scenario here using our stock images of Vince Vaughn and James Franco. So Vince says, hey, Dave Franco, we need you to come up with an ML algorithm that maximizes profits based on this data set. If we use a neural network, we'll minimize our loss function and get the best results. I don't know what he just said, but Dave's model made us rich. So what just happened here? Dave Franco was asked to find the best machine learning algorithm to produce the most accurate model. While Dave was successful in producing a very accurate one using a convolutional neural network, it might be very difficult to explain what his model did under the hood to someone who's not technical. So the point I'm getting here is that machine learning algorithms will be very accurate and will lead to major breakthroughs. However, the more complex the model, the more difficult it will be to explain to somebody who's not knowledgeable. So why is it that models are more difficult to explain than others? I think it can really boil down to three things. The first is the number of parameters. So the more complex a model is, the more parameters you're going to have to manipulate. The second one is going to be complex feature engineering. So you might have to use like polynomial terms or principal components. And then lastly, the computational overhead. So for some algorithms, you're going to have to run it many, many times in order to actually produce a result. So to incorporate myself into this presentation, I'm going to give you a real scenario I experienced last year with Possible Finance. So for this startup, Possible Finance provides short-term loans to low socioeconomic individuals. And what they're trying to do is provide a better opportunity compared to like payday loans. So I was tasked with the responsibility to automate their pre-approval process. What does this mean? So if you wanted to get a loan, an underwriter, like in a traditional sense, would look at your bank statements to determine, okay, how much are you making, how much are you spending, come up essentially with a profile to determine, should we loan to you or not. And so I was using machine learning to determine which of your bank transactions are income or not. So like, here's an example of what it would look like, where I would have a bunch of transactional data, and my goal is to essentially predict, is this line income or not? Once this is done, you can aggregate all this information in order to build that profile and determine how much are you making monthly, how much are you spending, et cetera, et cetera. So the outcome of this is that I came up with a gradient boosted model was the most accurate model to be used in this particular situation. However, I needed to be conscientious because while it's a great model, it's very difficult to explain how it's behaving and which features predicted if it's income or not. On the other hand, if you use something like a random forest, it's a lot easier because you can use feature importance in order to determine, if one feature has a better outcome of income versus another one. So like a good example is when I was using NLP on the transactional text. If you had a word like deposit, you had a higher probability that it's going to be income versus if you have a word like Chipotle, you're most likely not. And the other point behind this example is that while I handed this model off to Possible Finance and they can use it going forward, they need to be very careful. So for instance, like that example I used about text information, as new text will be introduced to the model, if it's not recognized, it may potentially lead to underestimating like a new customer that comes in, which could put them at a disadvantage to get a loan. So those are things you have to take in mind. So we need to be aware of our actions as we make or we code something that we write, because it can have big impacts on society. Thankfully, the data science community is aware of this. So for instance, how many of you guys are aware of GDPR? Great, because I can give you kind of a brief explanation of it. But for GDPR, or Global Data Protection Regulation, this is a loud warning from the European Union, essentially saying to all data scientists, we need to be transparent with what data we're using to train our models. And this is to protect the customer. So while there are many businesses out there that are not required to follow GDPR, especially in the US, our government can enact policies any day to require industries to follow these very specific requirements. A good example of this is like in the insurance industry. In certain areas, there are rules already in place that tell us which features are allowed and which ones are not allowed to be used towards your model. There are also rules about the limit of the number of features that we can use, and this is to reduce that potential for a black box algorithm. And then additionally, in the data science community, it's very well established. And with sites like Stack Overflow, Stack Exchange, Cross-Validate, and then also in our local Seattle community, we have many meetups. We have a lot of content to work with to help each other out so that we can do a better job with explaining things to society. So how does this tie to where data science is going to go in the next few years? So there are new tech industries are hiring data scientists at an alarming rate, and that's great for all of us. While I have my utmost faith that the right checks and balances will be in place to protect the customer, we as data scientists should always be prepared to explain our work. Many of us dread this as data scientists, but documentation is extremely crucial. Just like any employee, there's a high probability that we're going to change jobs at some point in our career. And knowing what one fellow data scientist did can help us when we take over their models or over their work. We'll also want to keep other stakeholders in the loop of our work, such as like legal and business, in case we potentially cross any lines that might be a gray area and we don't know what to do. And if you aren't paying attention to any of my presentation or you had trouble following along, I'll leave you with this. Having an accurate model is good, but explanations lead to better products. So my name is Samuel Bradley Keller, and I'm a data scientist, and thank you for listening.